What is up, all of Algebra 1 students? We miss you guys so much. I just got off of a Zoom with Mr. Green and Mr. Chavez, and we just want you to know that we're thinking of you, and we really do miss you so much. So today, what we're going to do, number one, I want to make very clear is that this is actually your first graded assignment. So make sure you're getting this completed and turned in, because you will have another assignment on Friday that will also be a grade. So we don't want you to start getting behind. Okay, so today we're going to start reviewing the 3 types of word problems that you have learned so far this semester. Okay, and so the very first one we're going to look at here is linear. Okay, linear word problems. And we know that linear word problems are y equals mx plus b, right? And m is our slope and b is our starting point. And so what we're going to do today is we're going to look through these word problems, we're going to break them down, and then we're going to do exactly what you're going to do later on. So it says this: researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Write a function that can be used to discover the thickness of the ice shelf in meters X days since the discovery. So the very first thing I actually want us to do is to go in and we're going to highlight. So we're going to pick a highlight color. In this case, let's just say yellow. Anything you might think is important. So the first thing that stood out to me is that we had a thickness of approximately 450 meters when it was first discovered. So when I read first discovered, I'm thinking like, okay, that's what it started out as. So I know that that's probably going to be my B. The other thing that I noticed is it says the thickness of the ice shelf is decreasing. So I'm going to highlight that as well. And I know that decreasing actually means subtract. I'm even going to write that in. Hello. At an average rate, rate of change slope of 0.06 meters per day. Okay, so I'm going to highlight that as well. So the very first thing we're going to ask that you do is you highlight anything and everything you think might be important for this problem. Okay, the next thing we're going to do is you're going to actually write that problem. And so the way that we're going to insert an equation to be able to solve this is we're going to say insert, and then we're going to pick equation. When you do that, it actually pops up right here. But then you have it right here. You can just hit new equation. So we know that it says, write a function used to find the thickness of the ice shelves in meters after X days since the discovery. So we're going to start out by saying y equals, okay? And then we started with 450, so we're going to say 450. And it was decreasing, which means subtract. So I'm going to say minus 0.06, and then I'm going to put x, because I know that that's what it was changing by each and every day. All right, I'm actually going to give you a chance now. So what's going to happen is something's going to pop up on your screen, and I'm going to zoom in so you can see it about this problem right here. You obviously can't highlight it, but I'm going to give you a little bit of time to read about Cynthia and create an equation for Cynthia as well. It should pop up right here on your screen. Okay, hopefully that wasn't too hard and you got it correct. If so, we're going to move on to our very next type of equation. So the very next thing we talked about in class was a systems of equations. So systems, there's actually a lot of different ways we can write these, but what we know about a system, it is 2 or more equations. 2 or more equations, okay? So let's read this together. The very first thing we know is there's going to be 2 variables within this problem. So let's read it. It says a bag contains 18 coins consisting of quarters and dimes. The total value of the coins is $2.85. Write a system of equations to determine the number of quarters Q and the number of dimes D in the bag. Okay, so again, the very first thing we want you to do is to highlight any information you think is important. So this one actually gives us the variables. I noticed that it says quarters Q. Sorry, I have to zoom out there. I'm going to highlight that, and the number of dimes, which we're going to use D. So I know quarters is Q and dimes is D, okay? I also know that this bag contains 18 coins right now, okay? So I know there's a total of 18, and then the other piece of information that might be important is that the value is $2.85. Okay, that seems like a lot of information. Now, this is one of those weird problems. You guys do have to know how much a quarter and how much a dime is worth. But I think we have enough information here. We can go ahead and start writing it. So again, we're going to come up here. We're going to hit insert. And then we're going to say equation. Once it's there, you guys can just hit new equation. So I know I have to write 2. The very first one I'm going to write is this total one. So it says there's a total of 18 coins. So that means the number of quarters, which is Q, plus dimes, which is D, should equal 18 total coins. Okay, so that's my first one. So I have my first equation, but I know I have to come up with another one. So I'm going to hit enter. I'm going to come up here. I'm going to hit new equation. Okay, now this is where I have to think a little bit more. I know that we're talking about money here. We have $2.85. So I know it's going to equal 2.85. But what equals $2.85? Well, we know that money stays with money. So how much is a quarter worth? A quarter is not worth 25. It's worth 0.25. Oops. Q, or you can say 0.25 if y'all want. Plus, a dime is worth 0.10 or 10 cents. D is actually going to give me that 2.85. And I didn't do that as a oh no. Let me do that really quickly again. So 0.25Q, and you could write this in a different order too. 0.10 D should equal that 2.85. Okay. All right. Again, we want you to practice this on your own before you get to your worksheet. So if you will, right here, I'm going to leave this on the screen for a second for you to read. Go ahead and answer this. It is going to be a multiple choice problem that pops up. Okay, good news, you guys. You have made it to the very last function word problem we are working with today. Okay, so this is my personal favorite. So when we are thinking about our last one, it is our exponential one, exponential word problem. So this is just like talking about when we're increasing or decreasing by a percent or a factor where we double, we triple, we go in half. This is what we talked about with those pictures and silly pictures of your teachers. So super important to remember that your a value here, our parent function is y equals ab to the x. So our a value is our starting point and our b is going to be our rate. Now this is the super important part when we're talking about b. Okay, so the way we calculate B is we say that if something is 100%, that means it doesn't actually grow or decay. So we're always going to start with this idea of 100% plus or minus whatever percent the problem gives us. Okay, so that's your very first step in calculating B. The second is that you need to then convert to a decimal. Your B value, put some extra exclamation points. Your B value cannot be 100 and something, okay? You have to convert that to a decimal. So it should be 0 point or 1 point. All right, let's go ahead and get going on this example. It says this: in the year 1900, the total number of metric tons of copper produced in the world was 495,000. Each year since 1900, the total number of metric tons of copper produced has increased, oops, I already gave a hint, on average about 3.25%. over the amount produced the previous years. Write a function that models the total number of metric tons of copper produced in the year that is X years since 1900. Okay, so the very first thing I want us to do is go ahead and go in and highlight everything we think is important. So 1900 is the starting point, that like just the year, but the actual starting amount of copper is going to be this 495,000. So I'm going to highlight that. Okay, it says each year since the total number of metric tons has increased. That is super important. That actually helps me to know for my B value, I'm going to add. You can even type that in. That would be super helpful for us to see. And we're adding 3.25%. All right. The very first thing I know in order to do this correctly is I have to calculate my B value. So I'm going to start by calculating B. So I know I start with 100%. I already wrote right here that I'm actually going to add that 3.25%. Okay, so 100 plus 3.25 is going to give me 103.25. Now, this is not actually your B. It's still a percent. We have to change this to a decimal. So what I'm going to do is I'm going to take this decimal and I'm going to move it to the left. I can also take it and divide it by 100. No matter whatever way you put it, B is going to become 1.0325. Okay? So that is our B value. We already figured out what our A value was. Now we just have to put those things together. All right, so again, you should already have this equation tool right here. Go ahead and hit new equation. We're going to say y equals, we're going to say our A value, which is the starting amount right here, you guys, that 495,000. So we're going to say that 495,000 parentheses, and I don't think this is working as an equation right now, so let me retry that. I'm saying new equation, y equals, there we go, 495,000 parentheses, okay, 1 0.0325. Now this is super important, and I know you guys will have questions. You're going to hit shift and close your parentheses. But to get that exponent, to get this x up there in the top, you're going to hit shift 6. You should still see that same mountaintop, that caret, whatever you want to call it, button, and then you can type in x right there. So again, you're going to hit shift and then 6, okay? Shift and 6. Now I do have one more problem I want you to try on your own before you start your assignment, so I will leave it right here, there it is, okay? So go ahead and get that done, and then you can start on your assignment for today. Thank you, guys. All right, you guys, you have officially made it through the teach section, and now you're going to start on what you would maybe call your independent practice if you're keeping it normal. So super important for you to know is you got to get this done, okay? And then you'll hit turn in when you're finished. But you're going to highlight any important information just like I did in the teach video. Friendly reminder, make sure you're inserting your equation, and then I put some things here. Here is an example of like an 100% perfectly done work. Now, I know you might get a little bit lazy, but we'd like to see as much of your brain, especially since we're not getting to see you in person. So you just have these 2 pages. That is literally it. Now, I do want to point out here at the bottom, things are a little bit different. So it just says, given the following 3 equations, write a word problem that corresponds. So basically, you're just going to work backwards. So in this last section I gave you, we created 3 word problems for you, and you're just going to work backwards to be able to go in and type those in, okay? We will be available for our office hours. If you guys have any questions at all, we are so happy to help you. We are grateful for you guys. We are thinking about you guys during this time. Know that we miss you, and good luck. Let us know if you need anything